Hi, in this tutorial we are going to solve a question related to carbon-13 NMR. The question asks us, assign the peaks in the following carbon-13 NMR spectrum to the specific carbon atoms in the given molecule. In order to solve this question, we have to start identifying different types of carbon in the molecule. Let's start. This molecule is an ester, and it has here an aromatic ring, benzene ring, carbonyl functionality, an ester group, and here the alkyl part of the ester. Okay, let's start labeling different carbons with letters. Okay, let's start from this carbon. Let's say we have here a carbon with A type, and here we have a different carbon B. Here we have a carbonyl carbon C. We have here on the ring an aromatic carbon, let's say D, and we have, since the molecule is symmetric, this carbon and that carbon are the same type of carbons. Then again, this carbon and that carbon, because of the symmetry, they are same type of carbons, F, F, and let's write the last carbon on the ring as G. After assigning letters to each different type of carbons, then let's match them with the with the peaks in the NMR spectrum. Let's start. I will start again from A. Here we have a primary alkyl carbon which has to appear all the way upfield here in the spectrum. So I'm going to label this peak as A because we expect that this is going to be this carbon. Then the next carbon, again, it's going to be an alkyl carbon, but it's next to an electronegative oxygen. So I expect this carbon appears in the upfield region of spectrum, but with respect to A, it has to appear downfield. So I'm going to the second peak will be coming from this carbon-13 nucleus. Okay, let's move to C. C is a carbonyl carbon, and we all know that carbonyl carbons, they appear all the way downfield. So there is a small peak here around 168, not 170. So this is probably the carbon belonging to a carbonyl group. So I'll label this one as C. Okay, let's look at D, E, F, and G. These are aromatic carbons, and we know that aromatic carbons, they appear like between 120 ppm to like almost 150. In this region, we expect to see aromatic carbons. Okay, let's look at which one might be which carbon. We can still assign, because it's difficult, they are appearing together, but still we can decide. Let's start with the D. D is very close to a carbonyl carbon, so we expect that it will be downfield. So we can assign that this is going to be D. Again, next one is probably E. Then probably this G is this small peak here, and F, we can say this big or longer peak. So basically we assign each peak in the NMR spectrum to different type of carbons in the molecule whose structure is given to us. Thank you so much for watching this video.